Huh?
Yes, it is.
Yes, I guess so. Okay. So first thing here.
Yeah!
You like Joseph?
Yeah,
At least he came.
yeah. I have business to take care of.
Copy.
Regarding physics and some interview I'm supposed to take tomorrow.
For where?
Aston University.
Oh, alright. Okay, so first question here. Explain EMF. So does anybody remember what EMF stands for?
Electromagnetic force.
Not electromagnetic force, close though. They're all very good answers, but no, not electric magnetic field. Yeah, electromotive force.
Can you open the window, please?
What?
Open the window.
Open the windows, yeah. It is, isn't it?
Because I'm here.
Avenue.
You what?
I'm so hot, yeah.
You're looking out the window.
No, I'm just looking like, there's just something there. I want to be free.
That's what it really looked like. He was looking out going, if only I could be out there now. I'm sorry, Avenue. Try to concentrate, okay? So who can give me the definition of EMF?
You told electromotive.
No, well that's what it stands for, but what is electromotive force?
The voltage, the potential difference.
Yeah, these are all okay.
Yes.
But you can even make it simpler than that if you want.
The voltage produced by a battery when it's not driving current.
Yeah, or like ideal. Like the ideal battery with no internal resistance.
We don't see.
But electromotive force, I would say, just to look at the words, okay? Force we know, of course, and electro we know, and what is motive? Well, what does motive mean? I'm looking at you, Curdy. What does motive mean?
Yeah, crazy.
Yeah, come on, motive. What's motive?
Motion.
Motion, motivate, yeah. So I would say the EMF is the force that gives rise to the flow of charge. In other words, it's that thing in the battery that makes the charge flow. I didn't want to say too much because it was only a 1 mark question, so it should have been something small and snappy.
So it gives what?
Rise.
Rise like in create.
No, rise as in cause it to exist. So, if you want to see here, electro, meaning that's the charge part there. Force, there's force there. And motive, that's the flow. So it's the EMF is the thing, and we haven't really said what that is, but it's the thing that pushes the current around. Yes? Avenue, please.
I'm paying attention. There
Yeah.
must be the thing that.
Yes.
Sometimes it look very.
Yes, okay, right. Moving down. You got that? Okay, now. A battery can supply a current of 0.8 amps through resistor R1. Across its terminals is 1.4. When R1 is replaced by a second resistor R2, the current increases to 1.2. So what you have here is 2 resistors, R1. Are you writing this down?
I'm looking at
Okay. R2. When a battery is in this resistor, the current is 0.8. And when you connect the same battery to this other resistor, the current will be 1.2. So what law do you think, or what rule do you think I should use here?
Ohm's law.
Yeah. Now maybe we should clear up, when do you use Kirchhoff and when do you use Ohm's law? So you can use Ohm's law when you're talking about one resistor, okay? But when you have more than one resistor or more than one thing like a resistor, then you can't really use Ohm's law, okay? So here, Ohm's law, V equals I R, and here V equals I R. Now in fact, it's the same voltage because, why would it be the same voltage? Same battery. So you have two equations, so let's solve these together. 0.8 or 1 equals 1.2 or 2. If you want to put them together. So you can get or 2 equals 0.8 over 1.2 or 1. Now what's 0.8? That's going to be 2/3 or 1. So that's your first formula. Or 2 is equal to 2/3 or 1. Now, we still need to know something about the voltage though. Okay? And he tells us also in the question. In the second situation, the voltage falls to 0.9. Okay?
Here? Okay, so V here is 0.9?
Well, it says here when the voltage falls to 0.9. So if you put a voltmeter here, it would read 0.9. Yeah? So yeah, basically the voltage is 0.9. So if I put V as 0.9 here, I could get or 1. 0.9 equals 0.8 or 1. Okay, so what's or 1 please?
1.125.
1.125. And then you can put that back in there to get or 2. So what's or 2 please? So just multiply that number by 2/3.
0.75.
0.75.
Sorry, where did you get 0.9?
It's given in the 0.9 is given in the question. Yeah. Can I have a calculator for a second? I'm sorry, I read the question wrong. Apologise. It's hot, so you'll have to excuse me, okay? I think the easiest thing would be just for me to remove all this. I know it's terrible, I'm sorry. So I'm going to go back in time. I know, I'm sorry.
No, I didn't
Right.
check.
Oh, good. Good decision. You're actually told in the question, not only are you told the current in each, but you're also told the voltage as well, kind of. You're told that there's a potential difference across its terminals. So I should draw in my little voltmeter here. So like here. Do you remember we did something like this in section A? So there's a voltmeter here and it reads 1.4. And there's a voltmeter here and it reads 0.9. So actually this is good news because it makes it a little bit easier for us, because now we have V equals 1.4 and V equals 0.9, and the current is going around like that, and the current is going around like that. Okay, so we have V equals I or So now OR1 will be V over I, and then OR2 also will be V over I. Okay, so what are those two numbers?
The first one is 1.75.
Yeah,
The second one is 0.75.
0.75. Okay, so that was actually part 1 of the question and then part 2. So in a moment, I'll go on to part 3. It's the reason for my confusion here, so you know, is because they give you a diagram, but the diagram is for the C part, and in fact they don't give you a diagram for the B part. So you have to read it and draw the circuit, which I drew wrongly at the start. Okay, and if you want a little bit of help, it's very similar to actually, the section A question. I don't know if you remember doing it here. So the circuit setup is like this, and what they call the terminals is the points up the top of the graph at either end of the battery. These are called the terminals. But the problem is, you wouldn't have known that really unless you've seen that circuit before. Okay? So just again, for vocabulary purposes, you see these points here? These are called the terminals. Those 4 there. Okay, can I go on to part 3 now? All right. Now, the next part is, we're told that there's a small resistance inside the battery. Okay, so there's a small resistance inside the battery. And we're asked to find the value of the internal resistance of the battery. Now again, I think there was something similar we did not so long ago in section A as well. Yeah, actually, this is like question the number 14 that I did in the section A questions. Again, you can see in the diagram, I don't know if you remember this, there's a small resistor inside the battery. So I'm going to redraw it now, put a small resistor inside. Wrong route. Can I scroll down? Yep. Okay, so what you have is this setup here. What's wrong? Nothing.
I just
Yeah, whose is that? It's annoying me.
just one shining here.
That's it.
I don't care.
Well,
Hey, it's your calculator, Avenue.
Yeah.
Yeah.
Selection, that's
Yes, yes. You do like Snell's law, I know. Okay.
Maybe.
bad boys.
Now, what was the first resistor value we got?
1.75.
1.75, and then the second case is like this.
0.75.
Well, hold on. And the second one is 7.5. So this battery here has a voltage. We don't know what it is, because remember that voltmeter, that only gives you the voltage from here to here. It doesn't give you the whole voltage, okay? It just gives you it for the resistor. And then likewise here and here as well. So normally, the voltage for a battery, when you don't know it, you call it this letter here, which looks like an E. But it just means the voltage of the battery. Now, which law should we use? We can't really use Ohm's law. Why not?
Because you have
More than one resistor. So we shall use Kirchhoff. And we can't use the junction rule because there is no junctions. It's just going to be the loop. So we start here. What's the voltage? E. And then I move across here. What's the voltage here?
1.75 I.
Yeah, but we already know it because we're told it previously. It was, what was the first voltage I gave you? 1.4. And then finally the voltage in the small resistor will be IR. And what was the I gave you? 0.8. minus 0.8 or equal 0. And likewise Kirchhoff here, that one minus 0.9 minus, what was the 1.2, thank you, or equal 0. Okay, so that's not too bad. You've got two equations here. Here's the first one. And here's the second one. And we want to solve them, just like in maths class. So, what I'm going to do, just minus them, yeah. In fact, he wants both, the E and the OR. So, minus first. So that would be 0.4 or equals 0.5. So or equals 1.25. Yeah?
Yeah.
No,
0.5 over 0.4.
Yeah. Yeah? And then we can put that back in here to get the other one. So that's my first answer. And then my second answer would be 0.9 plus 1.2 times 1.25. So what's that, please?
Yeah.
2 point, was it 2.4? Now, we absolutely must have an answer bigger than 1.4 or 0.9 because those were the voltages in the resistor. So the total voltage must be bigger than these. So that's good. And that's it, finished, that part. Now there's a C part as well. But just so you know, for that question, the marks were, don't worry, I'll go back to this. Here, 1 mark, 1 mark, and then 2 marks, 2 marks. So really putting these together, because I did it in one go, was 4 marks. Got that? Can I just go down?
Okay.
Yeah? Okay. Now, C part. I think maybe this is the one you were asking me about, or someone else was. So I'll draw the diagram. Here to here, and then resistor 10. And then here as well. Resistor here 40. And then there's one here as well. 60. And then here, it might look a bit confusing. He's saying that there's 10 volts. If you look here, he's saying that there's 10 volts between those 2 points. So in other words, it's like there's a 10 volt battery. So it doesn't look like a battery symbol, but it's 10 volts basically there. Okay, so I'll write it in here, 10 volt supply, or 10 volt battery, or something like this. Okay. And they would like, they would like you to imagine you connect a voltmeter here, and they want to know what's the voltage here. Okay, so that's all the information. So what rules could we use here? Well, we can't use Ohm's law. We have to use Kirchhoff's. But, I mean, we could add these together if we want to make it as one. I don't see any problem with that. To simplify it a little bit. So, if I put these two together as just one resistor, what would it be? It'd be 1 over R equals 1 over 10 plus 1 over 40. You know, remember this, yeah?
Yeah.
So can you tell me please what that'd be? That'd be
5.83.
After you flip it upside down?
Yeah.
So that means you get R equals 5 point, what was it? 5.83, yes. Okay, so what I'm going to do,
Is this 1 over 14 or 40?
40. Wait, is that not right?
No, it's 8.
Here's 8.
Yeah.
Okay, 8. Now I'm going to remove these 2 and replace them with 1. Okay? So rather than having 2 resistors here, to make it easier for me, I'm going to replace it with 1 resistor of 8. Okay.
Where are you drawing it again?
I'm just kind of emphasizing where the current's going. So I would say it's going around this way. Okay. Do we know the I? We don't. But he doesn't want the I. He wants the V. Okay, so let's see what rules I can write down. So first one, if I wanted to, I could write down Kirchhoff. So starting here, I get 10 minus, what would he be here now? 8i minus 60i equal 0. Yeah? Yeah, and you can use Ohm's law here to get the V as soon as I have the I. So I'm going to get the I first. And the I would be 10 over 68. What's that, please?
0.147.
0.147. Great. Now, for this part, I can just use Ohm's law. So V, which is what I want, equals I, which is 0.147, multiply or, which is 60. And what will that equal? 8.83. And that's the answer. And again, this one, 3 marks for that on the screen there. Do you mind turning the lens a little bit? It's a little bit blurry. There we go. What? Yes. Just one part left now.
That's C.
That was C, and the previous one was B. So what we've done is A, B, C. Now the last one, D. But the last one is where all the marks really go, because the last one is 10 marks out of the 20 for the question. So it's this D part which carries half the marks for the question. So these have been kind of small little questions, where it seems like the only really rule I needed to use was Kirchhoff's loop rule and Ohm's law.
Yeah.
And that was all. Okay, can I draw the last circuit?
Yeah.
Yes?
What do we have left to do?
In terms of new material, the atom.
So this is we finished only until book.
You're talking about the revision? I basically have one book left to do with you. So the stuff we have left to do, I just put it all in one book. Yeah, which is just the atom. Which isn't too difficult. But we'll start that tomorrow? Thursday? Our next class.
I think we're going to start after the break.
No, we're going to start on it before the break, because the lab's finished now. That's
The break is
The week after
next week.
next.
Yeah, so we have
you have 5 week and a 4-day week. Get back to the physics now.
5 week and 4 day week.
This week is a 5-day school week, and next week is a 4-day school week.
Oh, so that's where the additional one comes from.
Yes.
Okay, now we're done.
Good. Now let me draw this circuit for you. Resistor, 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 avenue, Curdy. You can be writing this down. Resistor, resistor, battery, battery. Yes, Curdy. Same question, final part.
I think we'll do something like that, right? Section A.
Yeah, no, just focus here. Guys!
You can.
I did in this book. I understand it here.
Guys, can you please draw this diagram down? 50 volts and then 4 volts. Now, this is everything they give you in the question. So they drew the currents in for you. So it's I1 here, so that means it's I1 here as well. Here is I2, so that means like here as well is I2. Here is I3, so that means here is I3. Okay. So the question is basically...
I'm just making silent because someone's calling.
For 9 marks, find I1, I2, and I3 for 9 marks, okay? So we use Kirchhoff's loop rule. And I think I'll use 2 loops, okay? So I'll make a loop here, and I'll make a loop here. And also we have Kirchhoff's junction rule. So how many equations do I need to make if I have 3 unknowns to find? 3.
3. Why 4?
We have 3 unknown.
So we need 3 equations.
Yes.
Yeah. Why is it 4?
Leave them alone. Now, let's start off with this battery here, and I'll take the left loop as my first loop, okay? So starting at the 50 and going around. So we'll do this together. 50, then what's next when I hit this one?
Minus 10.
Minus 10 I1, and then here? Minus 5 I1, and then here?
Minus 4 I3.
All the way back to the battery equals 0. So that's one equation.
That's 3, not 2.
Sorry, this last one is 3. And this is why mistakes happen. Now, the next battery, let's go here. So 4 minus 3 I2 minus 2 I2 minus 4 I3. Back here is
Wait,
0.
wait.
Yeah.
Where did you go from now?
I went around the right loop.
Okay.
Yeah, but likewise I could have gone around the whole one. The reason I didn't, well, maybe someone tell me, why did I not choose the loop on the outside?
Make it shorter.
True.
And because there's...
It gets a little bit messy when you hit the second battery. So that's my second equation. And then finally, we'll choose a junction. Let's choose the junction on the top. So what current is going into this junction?
1 and 2.
I1. And what's coming out?
I3.
I3. I1 and I2 are going in, and then I3 is coming out. So we get I1 plus I2 minus I3 equals 0. And that's your third equation.
So you can go up into drop.
I'm just going to remove these numbers here just to make a bit of space. Equation 1, 2, and 3, okay? So in red here, let's clean these up a little bit. So this one here would be, that's minus 15 I1. So 15 I1 plus 4 I3 equals 50. This one here, there's no I1s. It's 5 I2 plus 4 I3 equals 4. And then I1 plus I2 plus I3, minus last one, equals 0. Can I scroll to the right of the deal? Yes? Okay. So if you notice what's nice about the first two, what can I cancel in the first two? I can cancel I3. So I should subtract them. 15 I1 minus 5 I2. That and that is gone. And 50 minus 4? 46. And then underneath, I want to cancel the I3s from this one as well. So what I'll do is I'll multiply this by 4. And then I add them together. So now I have 4I1 plus 9 I2 equals 4.
0.
No, 4 plus 0.
Alright.
Yeah, it's okay? Right, can I borrow the calculator for a sec? Now I'm going to take a little bit of a shortcut here. I'm not going to solve these, I'm just going to say use matrix method or whatever method you want to solve these two at the end. So when you do solve them, out will come your answer here. I1 will equal 14 over 5 and I2 will equal minus 4 over 5 and then I3, how could I get I1, I3? Well, you can put I1 and I2 back into, I think this one here would be the best one.
We're going to put that one as the first one.
Yeah, whatever, it doesn't matter. So I3 will be then (18 over 5). Got that? And then there's just one part left. So here, getting those were 9 marks. Okay? Now, the fact that the middle one is negative is important for the last part, because in the last part they say, now just listen, which way do the electrons flow through the 4-volt battery? So if I go back to the diagram, what current is going through the 4-volt battery? Which one? You can see it there, it's I2. Now is I2 positive or negative in my answer? Negative. That means, or remind me, what happens when the answer is negative?
Just make it positive.
No, what does it mean for your diagram?
It was the wrong.
Yeah, you drew it the wrong way. So which way is the current actually going here? It's not going up, but instead it'll be going down. But he doesn't want to know which way the current flows, he wants to know which way the electrons flow. And then you have to remember also, electrons go in the opposite direction to the current. So in fact, which way do the electrons go then? Up.
Direction.
Yeah. So the answer would be the electrons are moving up in the diagram. Or in other words, you could say the electrons are moving towards the 3 ohm resistor. And that'd be the answer. So the last part now, the answer is, actually I'll just write it here. Electrons flow towards the 3 ohm resistor. And that's the last part for 1 mark.
So can you make a left?
Yes.